Hello, Algebra 1 students. Welcome to Lesson 8.3 on quadratic functions in standard form, right? You will recognize the form here because it's going to use our quadratic trinomial look polynomial that we used back in topic 7 a lot, right? This ax squared plus bx plus c look. So you're going to see that is going to be the standard form of our quadratic. This is the more typical way I think you see quadratic functions. And again, we got to talk about what we can pull from this formula so that we can graph our quadratic functions. All right, so it says, what information does C provide about the graph of f of x equals ax squared plus bx plus c? So again, this is our standard form for quadratic. And we're looking to see what does the C tell us, right? This C value here. Let me log us on to Sophos and we'll talk about what the C means. All right, so let's go ahead and go to Sophos and look at this applet together. All right, so it says we're going to use the slider, right, to talk about what happens with the movement, right? So if you look here, negative 2x squared plus 4x, notice that there is no C value. Right now, your C value is 0, right? So now let's move the slider. Let's go up. Notice what's happening to the blue parabola. It's going up. And then once the C goes down, it's going down. So notice it kind of helps determine the movement, right? I dare to say shifting. Okay. So now I want you to focus on the y-axis, right? This one. Notice what happens when I make my C value 1. What's the y-intercept? 0, 1. Notice what happens when I make my C value 2. Where's the y-intercept? 0, 2. Now let's go negative. What happens when I make it negative 1? 0, negative 1. So you can see that the C value controls the y-intercept, where it's located. So why does the original graph go through the origin 0, 0? Because its C value is 0, right? So that C value controls the y-intercept. That's one very good characteristic you should gain from a quadratic in standard form. All right, so let's talk about that more formally here. So we're going to write down that your C is equal to the y-intercept, right? And of course, that is the point 0, C. So over here, right, this blue graph, I'll do it in blue, this blue graph is here because it has a plus 0, right? Now if I meant to make that blue, sorry, plus 0. So its y-intercept is 0, 0, right? If I put a minus 3 at the end of this red equation, right, now it's going to shift this y-intercept down 3. Notice they're counting by 2s. I just got fooled. Right, actually they're counting by a half. So this is negative 2. So down to negative 3, right? And now everything gets shifted down 3. So 1, 2, 3, right? 1, 2, gets shifted down. Geez, this scaling is messing me up, right? So it gets down 1, 2, 3, right? This one goes down 1, 2, 3, and now here's your new parabola, right? Doesn't change shape, right? In terms of width, doesn't change the axis of symmetry. It just moves its y-intercept down to 0, negative 3. Okay. And again, why does this work? Well, again, every y-intercept has an x value of 0. So why don't we take this function, right, this general function up here, and plug in 0 for x. So f of 0 equals, so I don't care what a is, but x is going to be 0. I don't care what b is, but x will be 0, and then you have the c. Well, these terms with 0 are going to go away because it's going to be a 0 plus a 0 plus a c, which is just c. So f of 0 equals c, which means the point 0, c will be on your graph, and that is going to be the y-intercept. So an important observation there with the c value. Okay, so here's your formal introduction to standard form. So a standard form for a quadratic looks like this. f of x equals ax squared plus bx plus c. We just talked about the c being the y-intercept. The axis of symmetry, so there's still an axis of symmetry, it's still a parabola. The axis of symmetry is the line x equals, and I pronounce this as the opposite of b over 2a. Right? That negative sign, think of it as the opposite of b. Right? The opposite of b over 2a. That is also going to be the x-coordinate of your vertex. So you'll have an x-coordinate. So for your vertex, you'll have an x-coordinate of opposite of b over 2a. And then to find your y, you got to plug it in. So plug in this x into the formula, and you'll get your y. So we will still use the axis of symmetry and your vertex to create that symmetry line. And then we'll just look for 2 points to the left or 2 points to the right of the vertex, and we'll use symmetry to get 5 total points. All right, so let's do one of these on this video, and then we'll stop. So here's your function. What is the axis of symmetry? What's the vertex? What's the y-intercept? And we're going to graph it too. Okay? So this is our general formula, ax squared plus bx plus c. So it's a good idea to identify what a, b, and c are. So a is 2. Understand the sign goes with the number. So if any of these were negatives, they'd be a negative number. So b is 4 and c is 3. So let's find the axis of symmetry first. So the axis of symmetry is going to be x equals opposite of b over 2a. Right? So the b is a 4, so it's going to be the opposite of 4, which is negative 4. And then we're doing 2 times a. 2 times 2 is 2. Simplify this bottom, negative 4 over 4, and that's going to be negative 1. That is going to be where your axis of symmetry is. X equals negative 1. I can draw that line in right now. Go to where x is negative 1 and draw your dotted line. So now I also know the vertex has an x value of negative 1, but I need to find the y value. So to help me find the vertex, I'm going to take the value of negative 1 and plug it into my function. So 2 times negative 1 squared. Notice the parentheses I use. Plus 4 times negative 1 plus 3. So again, I'm just taking x and plugging it, or taking negative 1 and plugging in for x everywhere. Just type this in Desmos. Right? It's going to be 2 plus 3 minus 4. It's going to be a 1. Just use Desmos. So your vertex is the point negative 1, 1. This is your y value. This is your x value. Put it together. So negative 1, 1. I'll use blue. That's my vertex. Next, I want to find my y-intercept. Your c value is your y-intercept. Since your c is 3, that means your y-intercept is 0, 3. So I'll use blue there as well. 0, 3. Now, because of symmetry, that gives me a second point. I know there's another point over here to the left one at negative 1 or negative 2, 3. So now I need to find one more point. So either choose, so your choices are choose, and you can choose negative 1, 2, 3, negative 3, or 0, 1, or choose 1. One more to the left or right of the points you know. I'm going to choose 1. So plug it in. This is your x value. So f of 1 equals 2 times 1 squared plus 4 times 1 plus 3. That's 2, 4, and 3. That is going to be 9. So another point on your graph is 1, 9. So I'll graph that. 1, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then use symmetry. This point's to the right, so go to the left. And there's another point at negative 3, 9. And then I'll do my best job to connect this. It's going to be terrible, but I'm trying hard. There's that. And there's that. And there's your parabola. Notice it's kind of skinny because your a value is 2. Notice that it's opening up because your a value is positive. So a lot you can tell based off of your function ahead of time. And again, as always, you can just use Desmos to graph, but it's always helpful to know how to graph by hand. Okay, all right, so this is the first video. Second video is coming right up next.